Yeah, the limits and derivatives. You can see the definition of this. The limit of a function using intuitive approach. Definition is given. For a function f of x, if for x close to a implies that f of x close to L, then L is called the limit of the function. And we write this as a limit extends to a f of x is equal to L. That is a definition. So whenever I write LIM limit extends to a f of x is equal to L, the meaning is as x approaches to a, the value of the function approaches to L, where a and L are the numbers. A is a real number and L is also a real number. A comma L are the real numbers. What does it mean actually? I'll explain with some example. So the limits. Okay. Already we discussed in the chapter 1 the relations and functions. Some idea we know. We know the meaning of a function. So what is the meaning of a function? If I say f of x is equal to say x plus 3, what is the meaning? If you give any value for x, correspondingly the value of right side also changes, right? That means I can call this as y equal to f of x. Or if I draw in a Venn diagram, I can see that if this is x, corresponding f of x will be here. If I put x is equal to 1, I get 1 plus 3, 4. X is equal to 2, 5. X is equal to 3, 6. So 1 is connected with this, 2 is connected with this. So what is the meaning? So whenever I write y is a function of x, the meaning is as x changes, the value of y also changes. Depending upon the small changes in the value of x, the value of y also changes. That is the meaning when I say y equal to f of x. And we learned the domain also there. What do you mean by domain? The domain is what all values you can give for this x. So in this case, if it is x plus 3, it is a polynomial function. The domain is a real number. What does it mean? If I say the domain is a real number, the meaning is you can put any real number for this x. Accordingly, we can get the value of y. Any value you can put here. So here you can real number, the output also real number. Any values can be put for this. It's clear? But there are cases where we cannot put all the real number for the function f of x. Domain is restricted to some particular values. See, for example, suppose I take a function f of x is equal to 1 over x minus 3. If I give a function, this is also a function. My question is, can I put any value for this x? We cannot, yeah. So here in this case, what we write the domain? We write the domain as all real number except 3. That means you can put any value for this x except the value 3. I can put 2.9, 2.7, 3.1, 3.2, any value I can. Right?
Yes, sir.
So in this case, what we do, can I predict the nature of this type of the function? Suppose there is a physical system and that physical system is represented a function in this form 1 by x minus 3. And we know that when x is equal to 3, the function is not defined. Function is not defined. Right? But can I have an interpretation on this function when x is very close to that point? See, when x is exactly 3, I cannot find the value. But x is equal to say 2.999, I can evaluate this function. Correct? So based on this value, even though I cannot find the value, exact value of this function at x is equal to 3, but I can evaluate the function when x is equal to 2.999, etc. Correct? There is no difference between 3 and 2.99. They are almost same. Therefore, I can predict the nature of this function using 2.999 instead of x is equal to 3. It will give us some information. That information will be same as x is equal to 3. Similarly, I can put the value for say 3.0001. If I put it in 3.0001 in the calculator, I can get the value of this. Based on this, I can say what about the nature of this function. For this purpose, we are using the idea of limit. So, whenever I write the function limit extends to a, the meaning is the value of x is not exactly equal to a. The value of x is not exactly equal to a. The value of x can be a point very near to a. It can be from left side or it can be from the right side. So the meaning is when I write x tends to a means the x can be a point, a number near to a. Near to a. It can be from left side or it can be from right side. Right? See, for example, suppose I take a number here 5. So when I write limit extends to 5, what is the meaning? X can be any value here. Say x can be here. What is the left side? Left side of 5 will be, can be 4 here. If I take the natural number here, it will be 6 also. When I take x is equal to 5, x can be any point here, but I take a point very near to 5. So x can be, I can take a say 4.99, or I can take x is equal to 4.99, x is equal to say 4.999, etc. Or it can be x is equal to 5.01, or x is equal to 5.001, x is equal to 5.000. Therefore, instead of putting x is equal to 5 exact value, what I do? I put x is equal to 4.9, for 4.99, 4.999, then 5.01, etc. Then I get a one answer. Right? Based on that, I can say the nature of that function. That is the purpose. Sometimes it is very much needed. Practical application is there because no, sometimes I cannot find the value, exact value, but based on the value very near to that, I can find it. There lies the importance of the limit. I will give one the practical application why we go for this type of the approach. See, for example, in our circles, conic sections, such type of curve, we talk about what is a tangent. Even though we didn't explain the exact formula for the tangent, you know the meaning of tangent. See, for example, suppose I take an example of a parabola, correct? So I want to find the tangent at this point. Suppose this is x value and this is y value. And the corresponding, this value will be say 5. So I want to find the tangent of this parabola. See, for example, y square equal to 4ax at x is equal to 5. And you know the meaning of this tangent. Right? I want to find the tangent of this. So we know that tangent is a straight line, right? And we know the equation of a straight line. Many equations we learn. But because one point is given there, no? One point is given there, we can find the equation of a tangent. Correct? So we learned the equation y minus y1 equal to m into x minus x1. This is a 1.4, 2.4, like that all we learned. See, how can we find the equation of this tangent? That's the question. Because here only one point is given, no other information is given, only one point. So what we do, so for finding the equation of a tangent, since this is a non-figure, you can find the, say, you can find the value of m, because we find the derivative and we can find the value of m. Someone is there in the waiting. Yeah. So here, if the given curve is a non-figure, then we can find the value of m. Instead of this non-figure, suppose I give a one zigzag figure, say maybe a figure like this. I don't know the equation of this. I want to find the equation of tangent at this point. So only one point is given. And you know that for finding the equation of tangent, we need a minimum 2 parameters. Minimum 2 parameters. That means m will be given, point is given. Then I can find. Or if you are using a y-intercept form, slope will be given, c will be given. If you are applying for a 2-point form, you need a 2 values, x1, y1 and x2, y2. Minimum 2 points are there. But here, only 1 point is given there, x1 and y1. Only 1 point is given there. So how can we find the equation of the line using 1 point? It is not possible. We cannot find the equation of a line using a 1 point. I need a minimum 2. So in this case, how do you approach this question? So what I do in this case, since I need 2 values for getting an equation of a line, I take a point very near to that, somewhere here. I take a point. Then what I do? So this is the point A and this is the point B. I connect this. This is the equation of a line. But that equation of a line is not a tangent. It's not a tangent, but it is a line. And that line is somewhat similar to or close to your required line. Required line is the tangent line. So the given line is this one, AB. So AB is somewhat similar to or somewhat near to the tangent, but it is not exactly equal to tangent. But the idea is I can find the equation of AB. It is easy. I can find the equation of AB. Why I can find the equation of AB? Because the point A is given, the point B is also given. Then I can find. Then how do you get an exact equation? So what I do here, this B, I make closer to this. Say instead of this B, I can take B1. Then I draw a line. I get another line. Let me say it is a B1 line or a B1. That means when you compare to equation of AB and equation of AB1, what you can observe, the line AB1 is more near to your required tangent line compared with the AB. This process I continue. B1 come to B2. B2 means somewhat more near to your line. So I take a point AB2. What about B2? B2 is more closer to your A. I draw a line like this. I proceed like this. I find AB1, AB2, AB3, etc. When your B is, so I write here, when B is very, very near to A, the line become a tangent. So I can find the equation like this. Now the question is, very, very near to means what is the meaning? Can B be exactly equal to A? It's not at all possible. When B is exactly equal to A, we cannot find the equation of tangent because you get only 1 point. I cannot find a tangent. But when B is very, very near to A, I can find that one line. That line is almost similar to your required tangent line. This situation I can write like this. Limit X is moving to, or I can say B is, because B is the point here. B is nearing to A. I write here. B is not exactly equal to A. B is a point on the curve. A is also a point on the curve. When B is a point very, very near to A or almost equal to A. Yes, exactly. Almost equal to A. Your, first I say your AB is your initial line is same as your tangent. See how we frame the equation. See what is the importance of that limit. Why we are going for the approach of limit. We cannot find when B equal to A. We cannot find the equation of tangent. But still, we will be able to find the equation of tangent using the idea of limit. Why? Because when B is very, very near to A, there is not much difference between your original line and equation of tangent. That we can consider as the equation of tangent. I hope you understood what is the meaning of this. Now I write the definition of limit. So the definition of limit I write as this. Limit LIM x tends to A, the value of the function f of x equal to say some number L. So whenever you see this definition, what is the meaning of that one? The meaning I write here. When x is nearing to or approaches to small a, the function f of x approaches to L. Where a and L are number. Graphically, I can write this equation like this. X is approaches to A means A is a point on x-axis. Your graph will be a point like this, maybe like this. This is a point, say L. So L is a point on y-axis, A is a point on x-axis because x tends to A, this is a value of the function. Now you see, when x, I take a point left side. When x is moving to A from left side of A, what happens to this function? Each point you see, in each point when you see, when x is approaching to A, this value is moving to this point. What about this value? This value equal to L. It may or may not be defined. Sometimes this will, if it is not defined, I use the open circle there. Open circle. And x can be moving to A from right side also. When x is moving to from A right side, then also this is moving to this. So I write this situation as limit x tends to A minus. What is the meaning of A minus? The meaning of A minus is x is moving to A from left side. Your function value equal to L. And limit x is moving to A plus f of x equal to L. This is called a left limit and this is called a right limit. If both are equal, then we say limit exists and this is the limit. Because when x is approaching to A means approaching to A from left side as well as right side, then only it will have meaning. So try to understand the meaning of A minus means it is not negative A. A minus means it is not negative A. The value of x approaches to A from left side. If you want, I'll write here because that point is important. X tends to A means x approaches to A from left side of A. Approaches to A from left side of A. That is the meaning of A minus. Because minus I write the top of A. Right? A plus means approaches to A from this. This is a graphical representation of the limit. And approaches to A from left side, approaches to A from the right side. And if both are equal, we say limit exists. And one important point is, it is not necessary that function is defined at A. See, in this case, f of A is not defined. F of A not defined. Because when x is equal to A, exactly I cannot find the value. But when x is very, very near to A, I can say what happens. The value will be here. And there is not much difference between these 2 points. Therefore, I can take the value is also L, even though the function is not defined. That is the idea.
So
Okay,
could you let
now
Achyut in?
you can have any question you can have.
So Achyut's in the waiting room. Could you let him in?
Who?
Achyut.
Shoot. Okay. Yeah, you can go through, and if you have any question, I hope you have written everything, but all things I told you.
So what does f of a not mean on the right side?
F of a not defined.
So at right before f of a, like just before the value of a, it'll reach L, or will it be little lesser than L?
Yeah, almost near to that value. For example, suppose actual value of L is equal to say 5. What you are getting the value here is maybe can be a 4.99 like this. There is not much difference between. We can neglect that error. Therefore, what I can say, it is almost similar to 5. So I write the answer is equal to 5. Clear?
Yes, sir.
Yeah. So I think first slide also you have written. That is the tangent. Okay, that leave it no need. Just try to understand the meaning. What is the purpose of limit? Why we are using limit? When we are using limit? These things. Okay, now we can go through our note. Now we can read the note and see. Now we can read this one and see if you have any question. You can see. So definition is given there. Yes, any question? Can I continue?
So do we put like a random value for L, or will it be given in the question?
A value.
Okay, so we have to find the L value.
Yeah, it will be a value will be given. We have to find L, and
So we
you
can just
find
substitute.
L from left side as well as from the right side. If they are equal, then you can say the limit exists. Otherwise, limit does not exist.
So I don't understand.
Yeah, I will give the different situation where it exists or not. Okay. See. See the case where suppose I have a function. I will draw the graph better. Suppose this is x and this the point is a value. And one situation I draw here. This is extends to here and here. This is my function f of x. This is graph 1. Now graph 2. I take the same a and this point is L. I have a situation here. This is a point here, and say this is a point. See here. This is a function. It is a piecewise function. This point is a L1, and this point is a L2. And another case, I can have a graph at the point A, and at this point will be say like this. This is the point A. And the left side, maybe I can have a value like this also. This is the point, say, when x is equal to A is this. This is another situation. Or I can have a situation like this. The graph here also the graph going to this. You see this situation. In each case, I find the limit left and right. So what is limit extends to A minus f of x? Limit extends to A minus f of x means approaching to A from left side. So what will happen? This graph is moving to here. That point is equal to L. I find limit extends to A plus f of x. That is also L, approaching to A from the right side. They are equal. Both are equal. So I can say first graph, I can say limit exists. This is the conclusion. Limit exists and the limiting value is equal to equal to L. Now we take the second example. In the second example, when you find the limit, what is the left limit? X tends to A minus f of x. Can you tell me what happens when x moving to A from left side? This function is moving to this point. What is the value, corresponding value?
L1.
L1. So I can say corresponding value equal to L1. Similarly, limit x tends to A plus f of x. When x is approaching to A from right side, approaches to A from right side, the value is moving to L2. L1 and L2 are different. L1 and L2 are different. Therefore, what I can conclude? Limit not exist. Clear? Third case. When x is approaches to A from left side, how can I write? Limit extends to A minus f of x. This graph is moving to up, going up only. So what is the value? It is equal to infinity, plus infinity. And limit extends to A plus f of x, approaching to A from right side. Here also infinity. Even though we cannot compare infinity, no, even though both are infinity, we cannot say they are equal. They are not equal. Infinity we cannot compare. So what we do here also, what we say, limit not exist. So first case, limit exist. Second case, limit not exist. And the third case, limit not exist. Now what about the case 4? Let me write, this is a third case. Now what about the fourth case? Here, limit extends to, this is the point, say L. Limit extends to A minus f of x. Your value equal to L. Limit extends to A plus f of x. Your value equal to L. Both the values same. Both the values same. Correct? Here also I can say limit exists. So in this example, first and fourth case, limit exists. Second and third case, limit not exist. I hope you understood from the graph how can we find whether the limit exists or not. We can find. Now let me ask you one question. What is the difference between example 1 and example 4? Both are limit exist. Do you find any difference between example 1 and example 4? Or are they same? Yes? Any comment from your side? Question is clear. I have given example 1 and example 4. Example 1 also limit exists. Example 4 also limit exists. Do you find any difference or are they same? That's my question. one hint I can give you. Here, this is a open circle. Here, there is no open circle. Now, can you tell me?
So is it like L is not included in the first one?
Yeah, exactly. That means here the function is not defined, exactly not defined. Just like one example I have shown you, 1 by x minus 3. So when x is equal to 3, the function is not defined. So here, first example, f of a not defined. In fourth example, f of a is defined. That means even if f of a defined or not defined, we can evaluate the limit. No issue. Only thing is you find the left limit equal to right limit. And if f of a is also defined, we'll give another name for that. That we'll study later. We say it is a continuous. Here we are not using that word whether it is a continuous or not. Here we are saying whether the limit exists or not. So the only thing is for not to exist the limit, the left limit you evaluate, right limit evaluate, the value should be equal. It should be a finite number. That is why we are using the word L. L is a real number. It cannot be infinity also.
So,
Clear?
so why is for the fourth one f of a defined? So why is f of a defined in the fourth one?
Yeah, here f of a, when you put f of a here, no, the value is here also defined. See, for example, suppose I give a function f of x is equal to x plus 3. When you find from left side and right side, at the point, say, for example, 3 or 2. 2 plus 3, 5. Right side also 5, left side also 5. So f of I also defined. This situation we'll study later. Here we are talking 1, 2, and 3, but just I told the difference. Later we will discuss this also. The cases where f of a is also defined. Okay, clear? Any question?
So, why in the second case and the third case the limit does not exist? Could you explain that?
Yeah, because in the second case, what about the left limit? Left limit, you are getting the value L1. And the right limit, you are getting the value L2. For example, if suppose L1 is equal to 5 and L2 is equal to 6, they are different. In the left limit, you are approaching to one number. Right limit, you are approaching to another number. They are not same. Since they are not same, limit not exist. The condition for the limit is left limit and right limit should be unique. It should meet at a single point. It approaches to a same point. Then only we say the limit exists. And the third case, what happens? It is going to infinity. It is not a number. Infinity is not a number. Going infinity, I cannot find what is the exact value of that limit. Therefore, in the third case, limit not exist. We should get a number. L is a number. I told you. When I write limit extends to f of x is equal to L, that L should be a real number. And if you approach from left side and right side, it should be equal also. Clear?
Yes, sir.
Yeah. Any other question? Yeah.
In the
Tell
third
me.
case, we don't count infinity.
Infinity is not a number.
Okay. Yes.
Why we use the word infinity? Infinity is something beyond our limit, beyond our capacity to think, or beyond our capacity to evaluate. Then that situation we use the word infinity. Just like if I ask you how much water is there in the sea, we call it as infinity. Why it is called infinity? Because I cannot measure. At that time we are using. So that's why we cannot compare infinity minus infinity. I cannot write 0. Infinity minus infinity, I cannot write 0. We call it as a indeterminate. Its value we cannot find. Indeterminate. Something beyond our limitation. We have beyond capacity to calculate.
Yes, sir.
That's why we are using this infinity. We cannot. We should get a number. And that number should be comparable. I can say that, say 5. I know the meaning of 5. Then only I can say that limit. Otherwise not. Okay, fine.
Yes, sir.
Yeah. Okay. So finally, I write the definition like this. So in summary, this is the definition of the limit. Limit extends to a f of x equal to L means L is a number, A is a number, means one meaning I explained, when x is approaches to a, f of x is equal to L means limit x tends to a minus f of x equal to L, limit x tends to a plus f of x equal to L. So then only we say the limit exists. Its a left limit and a right limit should move to a same point, same real number. Then I say that limit exists. Otherwise, the limit not exist. That's why the cases I have shown you where that limit does not exist. We will show some example also there. Okay, in case I'll show some demonstration in post. 1 minute. Yeah, that idea is clear now. Let me change to another point so you can see here. So I want to evaluate this limit at the point say -1. So what happens? -1, you can see first you observe the graph. Let me make. So -1 is the point I want to evaluate, right? So what happens? I'll move this point left and right side. So look at x-axis as well as on the graph also. So when x is nearing to -1, so you can see both arrow moving to this one. What happens to the red color? Moving to one point. You can see that point corresponding to say -3.7 around. From left and right, it is moving to, see, when it merges, it will be merging to point on the graph. In this case, we say limit exists. This is the situation where the limit exists. If you take any point, always the limit exists. Left, as you can see, I have calculated the value also. Left value is -3.7 and the right side also -3.7. They are equal. Right? Now let me change this question to something else. Yeah, you see this graph. Can you see this one? I don't know what screen you can see perfectly.
Yes, sir, we can see.
So in this case, I am calculating the value x is equal to 2. You know that when x is equal to 2, the graph is not defined. When x is equal to 2, the graph is not defined. Right? So here, what happens to this value? I'm moving your graph from left and right side. When see here the point I want to calculate at 2. So I changed to 2. See? Now you see what happens to this. This is the meaning of infinity. See, you can see here. When x is moving to 2 from left side and right side, one graph going down, you can see one arrow going down and one arrow going up. So in this case, I can say when x is approaching to 2 from left side, your graph is moving to -infinity. You can see that violet moving to -infinity. Same way, x is moving to 2 from right side, the green color moving to the +infinity. One is -infinity and +infinity. In this case, we say limit not exist. You can say a question mark. Limit I cannot find. So I put there question mark. Left limit is minus infinity, right limit is plus infinity. Okay, let me give another example. You can see this question. This is the absolute value of x minus 1 by x minus 1. You see, I want to calculate the limit at the value 1. All other value it exists, but 1, what will happen? You can see. I'll demonstrate from here. So look at clearly. I want to evaluate the value of the function at x is equal to 1. At x is equal to 1. So when x is moving to 1 from left side and right side, what happens to the violet color moving to minus 1? You can see violet color is moving to minus 1. And the green color is moving to 1. You can see last, when x is exactly equal to 1 means very near to 1. What happens to the green color? Green color equal to 1 and violet color equal to minus 1. You can see in the right side I have written 1 minus, it will be minus 1 and 1. They are different. Left limit and right limit are different. So in this case, we say limit not exist. So these are the three cases: limit exist, limit not exist, and limit not exist in the case of infinity also. This is another example. Okay, I think it's okay, fine. It's clear? You can check any this value also. This is a step function. The step function is also defined at this integer point. It is not defined. Any integer point if you put, because this we studied in function, it won't exist. Okay, now we'll continue. Okay, now how can we find the limit using different methods? Okay, one example you can see here. And this approach, we call it as a numerical method. We call it as a numerical method of finding the value. Okay, let me give one example. This example you can do later. So I want to calculate limit x is moving to 2, x square minus 4 divided by x minus 2. And you know that when I put x is equal to 2, left and right limit are different. X is equal to 2, I cannot find, right? So what I do? I find what is limit x tends to 2 minus this function. So I draw a table. So numerical way I calculate what is the value. Graphical, just I explained to you how you do it this one graphically. Now I explain how to find this limit using numerically. So here what I do, I give the value x here, and here I find the value x square minus 4 divided by x minus 2. So approaching to 2 from left side, what is the meaning of 2 minus? So I give some value here, left side of 2. I can give, say, for example, 1.9. So I put 1.9 and calculate what is the value. So can you tell me what is the value if you put 1.9 here? Calculate and tell me. X square minus 4, instead of x you put what is the value? Yeah, when you put here, the value will be equal to 3.9. And instead of this, I change 1.99. What the value you are getting in the calculator?
No, shouldn't it be 0.39? Sir, shouldn't it be 0.39?
Why?
So 1.9 square is 3.61 and
Yeah,
then 3.
divided by, that you forgot, divided by x minus 2. Denominator also there. So denominator 1.9 minus 2. That is 0.1, no? Minus 0.1. When you multiply, you'll get 3.9. Correct?
Okay, sir.
Yeah. 1.9939 comes. What is the value? 3.999. You can verify with your calculator whether I am writing this correct or wrong. Okay. Now, what is your observation on this? See this function, point number 1. When x is equal to 2, I cannot find the value because denominator equal to 0. But I can evaluate the function when x is a point very near to 2. So I take some example. I put 1.9 and numerically I calculated this from the calculator. I got 3.9. 1.99, 3.99. 1.999, 3.9. So what we observe, when x is 1.99 is means it is approximately equal to 2. 3.99 means it is approximately equal to 4. So from this, what I conclude is when x is moving to 2 from left side, when x is moving to 2 from left side, the value of the function x square minus 4 by x minus 2 is moving to the point 4. So I can say the left limit equal to 4. 3.9 is equal to 4, approximately equal. Same process I do for the right side also. So what I do? The same thing I do for the right side values of this. So what I am getting, you can see. Here, this is x and this is x square minus 4 by x minus 2. So can you tell me some value right side of 2? I can have, this is 3, so I can have it some 2.01. It should be near to 2, 2.01. Now, tell me what is the value when you put 2.01 there? It can be 4.01. You can verify also. 2.001, it will be 4.001. 2.0001, it will be 4.0001. So here also, left side value is approximately equal to 2. Right side value is approximately equal to 4. So I can write from here, limit extends to 2 plus f of x, that is x square minus 4 by x minus 2. That value is also equal to 4. Since left limit equal to 4 and right limit, already we saw this in the graph. Left and right both are equal. I can say, this is the question, evaluate this limit. Evaluate. So this limit exists. What I conclude here is this limit exists and that limiting value equal to 4. And limiting value equal to 4. This is my conclusion. And this method, numerically I tried. Using some numerical approach, I find what is calculate and I find what about the left and right. I can say this limit value equal to 4. That means even though your function is not defined at x is equal to 2, you can find the nature of this function when x is a point very, very near to 2. That can be from either from left side or right side. Please note it down, these things. Is it clear now? Any question?
So, can we do like, now here there is x square minus 4 by x minus 2. then we can take x square minus 2 square, that is x plus 2 into x minus 2, and then we can cancel x minus 2 and x minus 2, and then when limit x gives 2, then we can get 4 now, like that.
That we will study in the case of a different method to evaluate the function. Here, whenever that is a reducible to that form. Okay, but whenever the function is given in x square minus 4 by x minus 2, what we can say is the function is not defined at x is equal to 2. Right, but limit
The function
value.
is not defined at.
Yeah, we will study this one. Then after this numerical method, we will study different method to evaluate the function limit. Right. So at that time, we can take that type of the method. Yeah. This method, what you said, is called a factorization method. That we will see the later section one by one. Sometimes you can apply rationalization, factorization. Some other methods are there. But there are cases where we cannot apply any of that method. At that time also, we can evaluate the limit in this method. Right? In this particular question, you can apply factorization. But there are questions where you cannot go for any factorization method or rationalization method. You can evaluate numerically and you can calculate the value left and right, and you can say, you can reach the conclusion, even though the function is not defined at that point. Is it clear?
Yes.